Hi there! In this lecture, we will learn about indexing, slicing, and iterating. First, let's create our array. You can see here I did something a little bit different from what we used in previous lectures. That is to square root every element in this array. Let's see the result. So everything is the square of the number. So first of all, we're going to learn how to index this array A. Let's say we want to pick this number. Now, we should know the position of this number in array A, right? This is the fourth number. But remember, in Python, counting starts from 0 rather than 1. So this is the fourth number, but its index is actually 4 minus 1, which is 3, right? So this will give us the elements. Now pay attention here. Here we use a squared bracket instead of a parenthesis. Once you notice that, you can just execute this command, and it gives you number 9, which is our desired result. That's how you index an array. It's pretty simple, right? I know. Then comes my favorite feature of NumPython, which is slicing. Slicing means you can not only select a single element here, you can also select a part of this array, a block of the numbers. How to do this? Well, you simply add a semicolon, and before this semicolon, you indicate where you want to start selecting, and after this, you put where you want to end the selecting. Let's say we want these numbers, okay? So 4 is the third number, but the index is 2. And 36 is the sixth number. However, please notice that Python will not select the last number in your index. So we should add 1. Let's try. Voila, exactly. There's some fancier usage about slicing. For example, you can omit the first parameter. So when you do this, you are basically selecting from the very beginning all the way to the 7th. Let's try. Another thing is you can also omit the part after it. So if you do this, you are selecting from the 7th element all the way to the end. Let's try. So from the 7th element all the way to the end. Now to make it even fancier, you can omit both, just like this. So this is essentially selecting from the very beginning to the very end. So you are selecting the whole thing. This is actually equals to A itself. Let's try. So it's A itself. The next topic I want to introduce is to iterate through the elements in an array. So to do this, you will need a for loop. So for I in, just put the array name here, and then you do something to I. This loop will go through each element in array A, where I equals to one of them one by one. Let me show you. If we print it out, just print I, we will get these elements one by one. So you can see this for loop is executed 10 times, and it prints out the 10 numbers in this array. You can also do something. For example, here we are taking the square root of I. So for each element, we are taking the square root of it, which will give us 0, 1, 2, 3, 4, 5. If you really think about this, this thing, square root, is actually a function. It's just defined by the NumPy library. You can of course replace it with your own function. For example, let's define a very simple function. Let's name it f, and it takes x as a parameter. And this function does is it returns 0. Yeah, I know, it's a very lazy function. It doesn't do anything to the parameter. It just simply gives you 0. Let's replace this with our own function. That's right. What do you expect the result will be? Well, it will be all zeros, right? Because our lazy function. Let's try. That's right. It's very lazy. So that's how you iterate through the elements in an array. Indexing, slicing, and iterating through multi-dimensional arrays is almost identical to the one-dimensional array. Let me show you. First, let's create a multi-dimensional array. Let's print it out. Oh, you can see this is our array. Well, why don't we just move this to a new block so it's much more clear. I want to pick this element, and it's on the second row and the fifth column. But remember, in Python, every index needs to -1. So second row is essentially row number 1, and the fifth column is essentially column number 4. Pay attention here. I use a comma to separate this index. You can think of this as a coordinate. Think of it in this way. You have your x-axis and y-axis, right? This will be x. This will be your y. You are very familiar with this, right? And the trick is, instead of this side is upside usually, the upside is this way. And for x, it's still this way. So now you can see this is the 0 point, right? The original point. So you can see the first element is actually 0 and 0. So 9 will be the second element here and the fifth element here. So this is 1, this is 4. So that gives you the intersect is number 9. That's how you can identify this. Okay, now let's see what NumPy thinks. Does it agree? Yes, it agrees. And you can also slice a two-dimensional array. You just put like this. Here, you will slice by the rows. Here, you will slice by the columns. If you slice the first column, the first row to the third row, and the second to the first, then we get this part of the array. Why is it? Well, because we're selecting from the first row to the third row, right? So first row and third row, remember it's exclusive, so not this row, not this row, so only this one. And from the second column to the first column, from the second column, this one is the second, right? And to the third, and remember the first column is exclusive. So this part and this part, the intersection will be this part, which is exactly what you got. You learned a lot in this lecture. Try to practice on your own dataset, and I will see you in the next lecture.